All right. Hey, welcome back. October 14th, 2020. So we're going to continue our study of inequalities. So take a moment, read the do now, and then answer it. And then we'll talk about it. But because this is a recording, go ahead and pause and you read it to yourself or follow along while I go over it. Colin has $30 to spend at a carnival. Admission costs $5. Lunch will cost $6. And each ride ticket costs $1.25. Can we write an inequality to represent the number of rides? Shoot. Okay. I knew that might happen. I had that feeling. You know what I mean? That's how it's been going lately. Let's see. Aha. Okay. Colin has $30 to spend. Oh, read that part. Okay. It says write an inequality to represent the number of ride tickets X that Colin could buy. So, I would normally invite someone up to explain what their thinking was. But we know that he has $30 to spend, right? So he can't spend more than that. So if you can't spend more than $30, what inequality sign might you want to say? If you can only spend up to $30, or at most $30, what might you say? Well, I hope you were thinking less than or equal to $30. Yeah, so if you're going to Carnival and you have 30, you can spend less than or equal to 30. All right. Now, we're going to work on the other side. Well, what adds up to get less than or equal to $30? Well, it costs $5 to get in. Plus, he plans on spending $6 for lunch. Plus $1.25 for each ride ticket. All right, we're missing one thing though. Do we know how many tickets he's going to buy or that he could buy? No, we don't. But we do know we could represent it with like $1.25 per ticket. And there we go. We have our inequality. And for fun, let's just solve it. Let's see how many ride tickets he could buy if he plans on doing it. So we'll simplify this side of the equation. Okay, and then once you take a moment and solve it, pause me now, and then we'll go over it. So, this would be much better with a calculator, but we can maybe do it. Let's see. It doesn't go in once here. How many times here? 8? Maybe 8? Let's see. That would be 10. Can it go 9? Oh, can't go 10, so it's got to go 9 times. So what is 9 times 1.25? Let's see, 5, 2, 11.25. So you can buy, I think, less than or equal to 9 tickets. If we go to 10, it's way too much. So there we go. Any questions on that one? So I guess this is maybe why we don't actually solve it, because you get a weird number. But Colin can buy 9 ride tickets if he's going to the park. Okay. All right, inside your notebooks, we're going to get into 2.4 and 2.5, solving some multi-step equations. So give yourself that heading, or maybe you print it up. Okay. How do we solve inequalities? That's what I would ask. How do we solve inequalities? So how do we solve inequalities? That's what I would do in class. Then I would take an answer. Someone would say, just like you solve equations, I'd be like, yes! Just how you solve equations. That's right. Let's go. Except, this is the exception. When solving inequalities, if you multiply or divide by a negative number, you must flip the sign to keep it true. Okay? So, that's why we spend time solving equations. We solve them so we can solve inequalities as well. So, I wanted to do this step one together for you. So, we look at the inequality. And the first thing I'm going to do is simplify the side. I'm going to do negative 3. If we do plus negative 3, you might see it better. This is plus negative 10. Now we can distribute. We get 2 plus negative 3x plus negative 3 times negative 10 is positive 30, which is greater than or equal to 30 minus 5x. All right, let's see if we can simplify the side. Can we simplify this side anymore? Yeah, we can. 2 and 30, right? 2 and 30 make 32, so we can say it's negative 3x plus 32 is greater than or equal to 30 minus 5x. All right. Now we can start doing things to both sides. It's really up to you. I'll add 3x. Sure, why not? We'll add 3x to both sides. And then we get 32 is greater than or equal to 30 minus 2x. And then we're going to take away 30 from both sides. And we get 2 is greater than or equal to negative 2x. Notice how I brought down the negative 2, super important. And then we're going to divide both sides by negative 2. So divide by negative 2, and we get that x over negative 1 is less than or equal to x. And there we go. There's our answer. Sweet. So everything less than or equal to negative 1 is going to work. And you're going to say no, right? And I'll say yes, this is false. That's our false answer. Because what we have to do is flip the inequality sign because we divided by negative 2. So we're going to have negative 1 is not greater than or equal to x. We're going to say that it's less than or equal to x. Okay, there's our real answer. Sweet. So it's the only time we divided or multiplied by a negative, and there we go. Okay, I have one for you and your neighbor to try. Haha. Well, you're not there, but I just want to show one thing. Ready? All right. Do we have a problem? Yeah, okay. So let's solve this one. We got this fraction over here. Well, how would we undo this divide by 3? And I'm hoping people say multiply both sides by 3. And I'm going to be like, sweet. Or some people say we could treat it like a proportion and use cross products. But for now, we're just going to multiply by 3. And now we get 3 minus 2x is less than or equal to, well, it's 3 times all of this. So 21 plus 6x. All right. Yeah, now we can just start doing things to both sides. I'm going to add 2x to both sides. Minus 21 from both sides. Oops. And then we'll divide both sides by 8. And we get negative 18 over 8 is less than or equal to x. Okay. Is this the real solution? Well, how you check? Did we divide or multiply by a negative? Look at our step here. Did we divide or multiply both sides by a negative? No, we didn't. So there's our real answer. We don't flip the inequality sign. Boom. We can rearrange this just so the x comes first. So we can say that x is greater than or equal to negative 18 over 8. And yes, we could simplify, but for time, we're not going to simplify. But you know, divide both by 2, you get 9 over 4. Okay. Okay. Sweet. So we'll keep going. All right. So we learned when we were studying equations that equations can have all real numbers or no solutions. And we're going to see the same thing when we have inequalities as well. Some inequalities will have no real numbers as a solution, no solution, and some will have all real numbers. Okay, so I want you to take a moment, copy these two down, and I want you to think and kind of reason through it. This inequality, x plus 5 is greater than or equal to x plus 3, that every number for x works, all the real numbers. 1, a million, negative 10. Any number you put in here that's real will make this true. There is no real number that doesn't work. Fractions, decimals, negatives, positives, square roots. Everything that's real is going to work. Well, most square roots. Anyways, okay, so this one is a no solution. There's no number that will make this side less than this side. You can put any number you want, and no matter what you put here and here, it will never be true. Versus here, everything's going to be true. The question I want you to do is write these down, try to solve them, and let's think about, reason through why this one, every number works, and why this one, no number works. So this will be a chance to pause, solve, do some stuff, and kind of think about why these are all real numbers and this is a no solution. Okay? Well, this is a recording, so I'm going to keep going, but go ahead and pause and we'll talk about it. All right. So, if we solve this, well, let's just talk before we solve it. Why does everything work? And usually students in each class realize. Well, if we look at this side, it's x plus 5. And this side is x plus 3. This side will always be 2 more than the other side. If you take a number and add 5 to it, will it always be greater than taking that number and add 3 to it? Yeah. Anytime you add 5 to a number, it's going to be greater than taking that number and adding by 3. So every real number, this side is always going to be bigger than that side. It's got to be, right? Like this has to be greater than that. It always does. All right, there's something that happens when you solve. That's a good another. Say you forgot for some reason. Say you started solving this, right? And I don't know, you took away 3 from both sides. And then you got x plus 2 is greater than or equal to x. And here maybe another sentence. It's something plus 2. Will that always be greater than that number? Of course. Or say you just weren't paying attention and you kept going one more step and you took x away from both sides, you would see that 2 is greater than or equal to 0. And so there's no variable. But what do you notice about the inequality? Is 2 greater than or equal to 0? True inequality. Cool. So that's another clue that what we're looking at is an inequality that always works. Every number is going to make it true that you put in for x. Every real number. All right. And then I would have students explain that, but it's cool. We're going to talk about it. All right, this one's a no solution. Did you think about why this one is no solution? And a student would say, well, first I distributed and then I kind of rearranged it so it looked kind of the same. And they would say that 2 times a number plus 6 will be less than 2x plus 2 times a number plus 5. Well, this side will never be less than this side. If you take a number and double it, then add 6 to one side and 5 to the other, this side will never be less than. This side will never be less than the right side. It can't be, because you're adding 6 and then you're adding 5. Like, this side will always be how much more? That's what I say. Well, it'll always be 1 more. No matter what real number you put in, it's always going to be 1 greater. You can try it with negatives, decimals, fractions, but this side will always be 1 greater, so it will never be less than. Right? Okay. You could see it if we solve it a little bit over here. Well, let's start solving things. And this time, let's work with x's first. So we take away 2x from both sides, and we get 6 is less than 5. Well, really quickly, is 6 less than 5? So we have no variable, and we have a false inequality. This is not true. So, 2 ways to know. This is a no solution because this side's going to be bigger than this side. It's never going to be less than. And this one, all numbers work because this side will always be greater than. And these are the 2 ways if you solve and you forgot, you might not know. So I want to give you the rest of the time to work on this classwork. I'll be around checking in when you submit. If you have any questions, definitely email me. So you got page 123, 13 through 19. 17 through 22 and 29 through 32, and whatever you don't finish is going to be submitted for homework, okay? And we'll go over it tomorrow if you're in class, or you might have to watch the video. Let's see. Oh, no.